Hello, everyone. Maybe I have a quick question. So, are you proficient in Kubernetes, or have you used the Kubernetes before? If you use it, just maybe text one, number one. No, okay, perfect. Okay, how many? Oh, kind of half and half? So not yet. Okay, great. Okay, I think today's session will fit all of you because I know it's kind of a generic Kubernetes sharing. So I also, no matter you are professionals in Kubernetes, or we do have that group. Okay, how you will? Oh, okay, I see. So we are kind of in the same field. Thank you. Mm, yeah. So what I mean is, so okay, okay. Oh, the learning DevOps. Okay, wonderful. Yeah. Anyway, what I'm going to say. So today's session, it will fit all of you. So no worries. You are professionals or you are not familiar with the Kubernetes. I will do my best to elaborate the theories and also the mysteries of Kubernetes networking architecture. And also, I think, George, we are definitely in the same field. We have the same networking background. Feel free to ask me questions. Yeah. I have okay, Docker. Yeah, it's really good because definitely when we dive into this session, we will also mention this Docker. Yeah, the kind of previous counterpart of Kubernetes. Okay, now let's begin. Let me do it. I wish I could do. Okay, so hi everyone, I'm Susie. I'm so very excited to be here to discuss the Kubernetes networking architecture. I think maybe as I just have a quick question for all of you. Some of you are in this field, some you are definitely out of this scope, but no worries. It's the reason why I'm here. And let me share you something. I think Jill, you mentioned you are a student learning DevOps. Okay, based on my experience, I do have, not me, because my background is networking. And so for me, it's not that complex, the Kubernetes networking. But what I can see, for example, like my coworkers, most of our coworkers and also my team members, they are suffering like, to understand the Kubernetes networking, for age. It's also the reason why I have planning, for, kind of elaborating this concept of a Kubernetes networking architecture for age. And luckily, I wish to share this good news with you. And my book, on this Kubernetes and networking architecture will be published very soon. So if you are curious, I hope you can just stay tuned. Now let's dive in. So a little bit about me. I'm currently working as a DevOps manager and a software operations architect at Signify, formerly filled with lighting. Here is a little bit one part of my CV, and you will see I have been kind of for 14 years academic software development, and also my experience related to the cloud compute like AWS, Cloud as well, and team manager and IoT Kubernetes. I have in this field. I could say I'm kind of a professional in Kubernetes for more than 5 years. And one more thing, when I was at my uni, luckily, I won the champion of the national networking competition, and so it's related to my background, networking, and also I passed and gained the 2 CCIE. I think B. George, you heard it. Yeah, this certificates. Yeah, it's just at the very beginning of my 10 years work. So let's step in. Today's outline, we focus on 5 aspects. Number 1, what is Kubernetes and also its purpose? And also someone just mentioned you are, kind of familiar with Docker. So here it is. We will do the comparison between Docker and Kubernetes. And since because not all of you are familiar with Kubernetes, or you even didn't, even you kind of a zero knowledge for Kubernetes, it's fine. I will share you some basic concepts and also common terms for Kubernetes here for number 3 part. And number 4, yeah, it's our main topic for today, Kubernetes networking architecture. But no worries, I know it's really complex, even for the experts of Kubernetes. It's the comments from them. Kubernetes networking architecture is really complex for them, and they are kind of people who just leave it because your networking is running very well. That's it. So somehow they do not dive into the networking architecture. It's so complicated. But anyway, I will give you real life examples. For example, number 5, I will give you the classic networking scenarios in Kubernetes. I hope it can make the entire concept easier. The first one. So what is the Kubernetes and its purpose? So I think, for all of you, definitely you can just search Google and get the professional definition of Kubernetes. But from my perspective, in very simple terms, Kubernetes is similar as an OpenStack equivalent for container orchestration. If you have been familiar with OpenStack, or if you heard it, the architecture, I think you can just understand the Kubernetes very well, because in the world so far, Kubernetes definitely is the most popular. The one of the most container technology. The previous one, the counterpart, is Docker, right? And what is the purpose? Okay, so Kubernetes is an open source platform. Yeah, it's both portable and extensible, designed for managing containerized and workloads and service. In simple words, previously we struggled in, previously we do not have a microservice. And if we wish to establish the website, it will just invest a lot of effort and to achieve this part, right? But when we involved the technology, container technology, such as Kubernetes and also Docker, it makes our life very easy. But the main difference between, so number 2, the architecture between, when we talk about Kubernetes, we definitely need to refer to the previous counterpart, Docker. But definitely, if Kubernetes is kind of a cluster, structure. So the similar equivalent should be Docker Swarm. Okay, let's just step into these 2 comparisons. The parameters. The first one, installation. I just want to check because I cannot see my screen when I just share the presentation. But anyway, okay, anything. Oh, sorry, someone just equivalent Docker Swarm. Okay, sorry, I cannot just read your question so far, but let me go ahead. We will just have Q&A in the end, no worries. So installation, okay. So for Kubernetes, installation is a little tough. Yes, I know. But once completed, cluster design is stronger. Yeah, because it's related astonishing Kubernetes network architecture. And for Docker Swarm, yeah, definitely installation is quite simpler. but the cluster is not as stronger as Kubernetes. So it's the reason why I shared this topic today. And also graphical UI, like Kubernetes is available, and for Docker Swarm, no. And scalability, yes, is very, very great, but a little bit limited speed. For Docker, definitely highly scalable and 5 times faster than Kubernetes. Outscaling, yeah, for Kubernetes is really robust architecture, and also the networking platform is really amazing. And the updates rollbacks, but for Docker Swarm, doesn't support rollbacks. And data volumes, yeah, and the shared data within the container only for Kubernetes. And for Docker Swarm, it can share data stored on other devices too. And the monitoring, yeah, and the logging, yeah, definitely is quite also important. They are inbuilt tools for monitoring and logging, such as Prometheus, etc. And Docker Swarm need to use third-party tools like ELK for monitoring and logging. Here is a Docker architecture. Docker's architecture use a kind of a CS model. CS mode. What is it? It's kind of client service mode. So, for example, like we have the Docker build. Client send the request to the Docker host through the Docker daemon, and to build this image stored on the Docker host. When we Docker pull, it will through the Docker daemon on Docker host, and get the from the remote registration registry to get the images, and then get it stored in Docker host images. And when we Docker run, it will go through the Docker daemon on Docker host, and to run with these specific images to create this container. So that's the Docker architecture. What should I say? It's quite simple, right? And how about the Kubernetes architecture? Wow, it's quite different. You see, the left side is control plane, and also the right side is a worker node. It's kind of a control plane and worker nodes. This combination of this kind of mode is very different from CS mode. And also for different cloud providers, for example, like AWS or Alibaba Cloud, they have another name. For Ali Cloud, it's called master worker mode. But anyway, it's the same, just different terms. And for this part, we will use the control plane and the worker nodes to differentiate the Kubernetes architecture. For the left side, you will see, okay, no matter UI or CLI, we can, to access the control plane, you will get it. What is it? There are a lot of components in Kubernetes. The first one, API server. It will relate to to control, to config, etcd, and controller management, and also scheduler. And for the right side, the work nodes, for each, you will see for each work node, different colors, and the Kubernetes property, right? And the Kubernetes and the container runtime. For each node, they will have these 3 quite critical components. What Kubernetes proxy for? I will tell you later, but here I just give you the quick answer. For example, like a Kubernetes proxy is for service networking, and Kubernetes you can regard it as the node agent, and the container runtime, any kind of pod containers or how they run, is related to container runtime. The third topic, okay, basic Kubernetes concepts and terms. What I mentioned, just the previous diagram, and here is the details. And the dotted line, the left side is control plane. The solid line, the right side is worker nodes. So what is what it is for each component. And you will see with the start, marker start, it means optional components, especially for, the cloud providers. I will tell you later. So first, controller manager. Okay, what does it do? So run all built-in controller like a node or replication controller. I just want to make sure. Okay, is there any question? Okay, good. Let's go ahead. Like node or replication controller, and the scheduler distributes and schedule the workloads across the available work nodes, for this one. And class DNS, here is mark start. So it means optional components. So what it is, it provides in-cluster DNS for pods or service. And also here, the cloud, because there is a controller manager, right? But for different cloud providers, such as, cloud controller management, runs cloud controller processes. And that take care of like, for example, like a node outscaling, create DNS entries, etc. And API server, okay. It's tracking state of all cluster components and managing interactions between them, right? And etcd, well, it's quite important. Key value store for all cluster configuration data. On the right side, you will see the work nodes. As I mentioned, three very critical components. What they are? Kubernetes proxy, okay, accepts and controls network and connections to the nodes ports. And also the kubelet is, as I mentioned, kind of a node agent. So manages containers based on incoming pod specifications. And the container runtime. Okay, this runtime that implements like the CCIE or like CIO and all containerd. Yeah. And also here, is a cloud provider is also optional components. It's called the cloud provider API. As I mentioned, like, API to manage cloud, right? So it will, cloud controller management will talk to this cloud provider API, like AWS, Azure, GCP, etc. Okay. Today's main topic, Kubernetes networking architecture. Let's dive in. Before we go, actually, no matter you are familiar with Kubernetes or not, it doesn't matter. But I think all of you are familiar with the Linux, right? And if you are definitely, your background, system engineer or Linux, you are proficient in or familiar with it, it's perfect because it means Kubernetes networking, it won't be difficult for you anymore. Because what? Let me tell you the reason. Kubernetes, this cluster, yeah, or you can regard it as like container technology. This Kubernetes tool is running on Linux, right? So definitely, for any aspect of Linux networking, you can find the equivalent, aspects or components or the concepts in Kubernetes as well. So here I give you a lot of, not a lot, just 5 very key Linux networking terms. So first one, network namespace. But no worries, if you have no idea about Kubernetes networking, look at this table. I will also give you, because I mentioned there are 5 very important Linux networking terms, right? So it's not just term, it's you can regard it as like components. So you can also find the equivalents for Kubernetes. Here is a table. So you will definitely see 5 tables that I wrote. What is a network namespace for Linux networking? Okay. Let me tell you what is the network namespace. It's for isolated isolated the network. So for different container or for different precise, put in the different namespace means these two process or these two container, they definitely in isolated network. They cannot connect each other, directly. That's it. Let me just share you something. You will definitely understand what I mean. So for example, here is all experiment related to the Linux. And then let me tell you, here is, we kind of create two network namespaces, net and NS1, net and NS2. Okay, you got it, right? For a net and NS1, you got the IP address, you configure the IP address, for example, like 10.1.1.1. And for net and NS2, you configure the IP address like 10.1.1.2. So when you configure everything, related to this network namespace and configure IP address, and then you will use this network namespace to ping the network namespace too. Network is unreachable, unfortunately. Why? So you have to activate the VETH pair to up. Otherwise, you cannot make it active. So when we just, to make the IP link set VETH1 or VETH2, this virtual interface up, and then it will light the both, the two IP address into different network namespace, ping each other successfully. So here is the result. Did I mention the VETH pair? Sorry, is something, is something wrong because I mean the virtual interface. Yeah. And go ahead. Here is a VETH virtual Ethernet pairs is what I mean. So for as I mentioned, for the different namespace, if they wanna just connect each other, we use this VETH pair to achieve it. So if you just regard it, definitely you can regard this VETH pair as a network cable. For example, the left side may be host 1, and the right side for the namespace NS2 is host 2. They are in different namespace, but there is network cable to connect each other, so they can transmit and communicate with each other. So it's the VETH pairs. The second terms, important terms. The third one, network bridge interface. Okay, so here is a Docker bridge networking in Linux, but no worries. For Kubernetes, it's a completely same, just change the name. It's for Docker, it's Docker 0, but for Kubernetes, it's called, for example, because for Kubernetes networking, for this bridge interface, they have so many different plugins. Take Flannel, for example. If you the Kubernetes networking, the network bridge is called CNI0. Okay, sorry. And then look at this diagram. You will see, we have a lot of different VETH pair, right? And this kind of, now I think you definitely understand what it looks like for. If you do have, I think George definitely you understand it. It's kind of a switch, right? Layer 2 switch for in the networking concept. So what's a little different? Because here you will see for containers, here's the containers 1, 2, 3. And for containers ETH0 and the port, the Docker 0, there is a VETH pair. And for to achieve container 1, 2, 3 to communicate with each other, right? And in Linux networking, this is called bridge interface. And for Docker, here it is. It's called Docker 0. And Kubernetes, yeah, it's in CNI0 in Flannel plugin. The fourth terms, net filter and IP tables. actually here is the network filter and IP tables. It's completely, not completely, I think it's kind of 80% different from Linux network. And look at the left side, for example, like a net filter is kind of underlying network filter for Linux. I will show you later. And for net filter IP tables, it's similar like for Kubernetes IP tables. But for Kubernetes IP tables mode or IPVS mode, what does it mean? It's a rules. It's not a tool. It's because previously I mentioned the Kuber proxy, right? I mentioned it's very important for service networking. And what did it do? It created a load balancer, and this can generate these IP tables rules to achieve the service networking and to find this specific service, the backend. I mean the destination ports, right? And look at it. Actually, it's simple. For net filter, it's kind of in Linux, it's kind of a kernel layer. And then you use in the kind of, you can regard these IP tables as a application. It can achieve more and more features, but the core is net filter. So that's the Linux difference, right? But for Kubernetes, the equivalent of net filter is IP tables in Kubernetes. And the net filter IP tables, I mean, these rules, it will, the equivalent of Kubernetes is this. Let's go ahead. And also here related to the network policy, right? Because it's also related to the security. How can we achieve the network policy in Kubernetes? So here is the Kubernetes master on Kubernetes. There's another name, control plane, no matter, but it's the same things. And here is a policy and API. So it will go to the listener and to distribute the network policy for different nodes and pods, etc. And for network policy support status in CNI plugins, because it's a container network interface plugins. Oh, for example, as I mentioned, there are so many plugins for support this function, like Salem, Flannel, Calico, Veeam, Night. Okay, so what's the difference between among these different plugins? So we will focus on network policy. Yes, okay, Salem, great. Flannel doesn't support network policy, and here the last two, yes. And look at it, the fourth column, you will see the network setup. So for Salem, it's kind of IPv6 or IO7 aware. Flannel is kind of layer 3 IPv4 overlay network. And Calico, and it's layer 3 network using BGP, but they achieve the same thing, overlay network. Midnight is kind of mesh overlay network. It all achieves something. I will tell you later. Okay, the fifth terms, routing. If you are, if you are not familiar with Kubernetes, doesn't matter. Or if you are familiar with it, or you have configured Kubernetes before, it will help you a little bit. But anyway, I will still tell you there are kind of 4 types of IP address block. What is it? If you are configured, you'll definitely understand what I mean. So for pod network, there is a CIDR. For service, cluster IP range, and also the node network, CIDR, and also the service external IP range. What is it? Okay, for routing, definitely, because you know we have a container, this concept in Kubernetes, container, pod, and node and service, right? For pod to pod cross nodes is something we need to involve third party tools to support this pod to pod cross nodes routing, because it's not like VETH pair or bridge or Dr. Zero or this CNI zero, this network bridge can achieve. And for port-to-port across nodes, definitely we need involve these routings like overlay network, right? So for Linux, there are a lot of kind of things can achieve the port-to-port across different nodes, because port-to-port means they are in a specific subnet and the nodes in another subnet. It's kind of a port-to-port network over nodes network. How we can achieve the network over network to communication with each other between port to port. Here is, VXLAN, GRE, IP, Open switch, they all can achieve that. But for Kubernetes networks, we call it container networking interface plugins. For example, like Flannel network tab, like UDP, VXLAN, host-GW, and the cloud provider VPC, and alloc. Yeah, I will tell you this because for specific cloud providers like AWS, Alibaba, they do not use like any kind of they do not use like the common method to do the routing part. For example, like a Flannel, they do not use the Flannel directly because they can take advantage of their VPC to achieve the optimized networking routing. So it will kind of decrease the processing time very much. So it's quite a optimized approach, also or rather solution. So for them, they configured this type, Flannel type. The name is alloc, or specific name. It's not UDP VXLAN, because if you just seriously to delve into this different like UDP VXLAN, you definitely understand for each of them, it precise the time a lot and also the CPU memory a lot. It's not nice, but if you take advantage like cloud providers, kind of customized API. Actually, it's not API. It's just called VPC. They take advantage of their inbuilt system and then achieve the best way to do the routing part. And also other part like Cilium, Calico, etc. Okay, so as I said, for example, like the Kubernetes overlay network, we use a Flannel, right? We just kind of establish a tunnel between this port to port. And for Linux, by default, they can involve this technology. VXLAN. It's kind of an overlay network. Okay. Kubernetes, okay. Okay. Someone just type something. Okay, anyway, Linux. Oh, I just want to share you what I mean. You can find that the equivalent, technologies already in Linux. Okay, so this is a routing table. This summary, like a node-to-node routing. Oh, it's easy. It's just quite a common layer 3 routing. Oh, wait a moment. For Linux and Kubernetes, that's same. And okay, for NetFilter, okay, is as I mentioned, like a service routing, right? But do not missense it, because here is in IP tables. It's not the IP tables tool in Linux. It's IP tables rules. It has been generated by it's created by Kubernetes. It's kind of a load balancer. And also network policies is related to routing, ingress controller, external routing, etc. Wow. Number 5, the last one, classic networking scenarios in Kubernetes. I think then is our main thing for today's session. I hope just after this kind of 5, yeah, I remember it's 5 or 6 or yeah, scenarios, you will definitely understand it because yeah, I just want to tell you, yeah, I know Kubernetes networking is very complex, but in the end, I will just tell you, it can be described by a few words, and yeah, you will get the whole picture. That's it. First one, between container to container. Here's the container. Yeah, it's also kind of a review what I mentioned before, over the past 4 aspects. It's kind of a good time to review, right? And no matter, yeah, it's kind of just like you bring to review anything you have learned from over the past 4 aspects. And the first one you will see here is container 1 and container 2. Here is a pause. There's something extra knowledge. But think about it. For every pod, you need the pause. It's kind of a crucial one because for pod connect containers, what I say is a mandatory container. Yeah. So for every pod, you must have this. Yeah. Just leave it. No matter. We will focus on container 1 or container 2. How these two can communicate with each other. Actually, you will see. First, pod network namespace, as I mentioned, the first concept or term in Linux is a network namespace for escalating the network, right? So for pod, they have the specific pod network namespace, and for the node, they have root network namespace, for the escalate the network. And for container 1 and container 2, they shared the network namespace. So what does that mean? It means connector 1 to connector 2. You can regard it as two processes in Linux. It view container 1 to connector container 2 directly. You do not need to do anything because they are in the shared network namespace. And second, pod to pod. For example, like a pod 1 to connect the pod 2. Okay, for pod 1, the IP address is here, 1.172.16.1.100. And here is a 100, yeah, in the same subnet. And you see, for this part is for the node 1, or node IP address. And you will see, okay, how they connect each other. Do you remember? The second term is VETH pair, right? But we will definitely involve the bridge because if a lot of VETH, we need to connect each other, right? And here it is, CNI 0 for Docker. Yeah. And then you will realize which plugin we are using, right? Flannel, yes. And what it will do? The first, the ETH0 for containers. Do you remember the previous diagram? And also there is a VETH pair, to all kind of this container, the pod. Forgive me. The pod one is ETH, not for container. Okay, and for pod ETH0, and it will have the VETH pair to connect each other and to you can think about the plug in to the switch, layer 2 switch, right? CNI 0. And it will from the packet will from the pod 1 to this bridge and then go to the specific pod 2. But think about it, because they are in the same subnet, so it's the reason why you can achieve it only relying on the VETH pair and also the bridge, network bridge. But if the pod cross nodes, for example here, is 1.100, is 2.100, they are in different subnets. How we can achieve it? Because think about it, for this node, they are in another subnet, right? Or you can regard it in another network. And here is in parallel, there's another network for pod. How we can achieve it, as I mentioned, overlay network. a different, like a Flannel, this plugins or Cloud VPC routing. Did you remember? Like specific AWS and Alibaba, for specific cloud providers, they have optimized, solution to achieve a port communication cross nodes, not in the same. In the same, they're easy. So we can achieve from, look at it, it's all same, pod networks, pod 2 networks. Okay, container 1 wish to communicate with 2. First, it will, not container 1. We are talking about the port. Container 1 is something more. And the port 1 to connect the port 2, it will, the package will from here to the bridge, and then plug in, to cross everything over the L3 IP routing, and to go to redirect. You can get it. Redirect the packet to the peer side of over network of Flannel peer side, and to go to the bridge again and return to the port 2. So that's it. So, okay, here it's about the containers because, okay, let me tell you. For port to do service, for example, here is port 1. We want to go to the destination. So service 2, it's kind of remote. Think about here. Yeah. And so what it can achieve. So first, here you get it. IP tables, IPv or IPVS model, doesn't matter. It's created by the Kubernetes proxy. It's a load balancer. What it can do? Okay, so here is port 1. We want to connect to communicate with service 2, and what we can achieve it. So first we cross the bridge. We go to the IP tables rules, and when we just touch these IP tables, it will generate. It will just trigger the translation table. It will tell us service 2 mapping to let me just wait. Port 2 and with the port 2's port number, and then it will tell us which port it will go to, right? And service to port, what you can achieve it is similar, but it's just from here to here, it will trigger the IP tables, this load balancer first, and the service 2 to port 1, right? And then the source is kind of a source node. Yeah, you can regard it as a kind of S node, and from the port 2 and the port 2's number to this port 1. Yeah, that's it. And how about the internet and the service? This will involve the ingress. And how we can achieve it? We definitely first to get this ingress controller. And here is the ingress for these rules. Here you got this host like example.com, and go to this path like app, and you will can direct your traffic to this service, my service. Yeah, this is service name, and the port number is 80. Yeah. Wrap up. So for node to node, physical or virtual host routing, yeah, it's easy, right? And for port to port, overlay network or other network plugins, we can achieve the port to port. And service to service, we use Kubernetes proxy, IP tables, etc. So in one word to summarize, what is Kubernetes networking architecture? It's actually simple. It's service load balancer over pod network and over node network is equal to Kubernetes network. Okay, here is a Q&A. Okay. Hello, everyone. You can ask questions. Feel free to ask questions. You can just tap your question, or maybe you can speak out directly. I think. Hello, are you sleeping? But anyway, I hope you can ask me question. Here is a Q&A session, and anyway, here is my QR code. Feel free.
Okay.
Hi.
I have a question. So basically,
Okay, perfect.
I would like for you to recommend like a resource for one to kind of learn networking fundamentals. Like I feel one has to understand networking fundamentals to be able to grasp the Kubernetes networking architecture very well.
Okay, thank you. I'm really grateful. So happy to hear that. Okay, thank you. And anyway, if you have any question, just scan this QR code. You will find my official my personal official website. You can leave. You can just find my email address. It's easy. xpetersu@gmail.com and send me anything. And also you can get my articles. Did I mention? Oh yeah, my book. Yeah, my book launch. So definitely, I will also share my upcoming technical books on my website as well. Feel free to subscribe. It's free because I just want to do something, for the open source and sharing. And here is just, I'm. Okay, sorry. Jill has some questions. My question is, when you talked about orchestration, it's like a Kubernetes, like a container, containers of containers. I didn't see a container for container, sorry. Because, I know what you mean. Because Kubernetes is a container, it's a container technology. It's one of the container technology. The equivalent is, for example, you are familiar with is Docker. And what I'm going to say, I mentioned because today we are talking about Kubernetes networking. So I mentioned like pod network or survey, pod network over the node networks. I never see something like a containers for containers. Yeah, it's not right. I have to say, because for Docker, it's a very simple networking. But for Kubernetes, it's not complex, right? When I finish everything, it's not complex. When you just have this structure of the Kubernetes, you will see, wow, it can scale up very amazing. And you can build kind of millions of applications on Kubernetes cluster, right? With this strong and brilliant networking architecture, right? So it's a quite important thing. Yeah. But for Docker, it's very kind of a client service mode. You can regard it like the only the network of node part with pod. It's kind of a NAT. It's a one layer network. But for Kubernetes, you see, you got the load balance part, the service network, and also you got the pod network. It's dramatically escalated from the node network. So you can achieve everything, in this Kubernetes cluster, completely separated. For anything, underlying like the IaaS, like AWS, Azure, Alibaba, etc., this cloud, you can just regard it like infrastructure layer, and you establish your Kubernetes there. You will only focus on your Kubernetes and the application there. You do not need to care about infrastructure layer anymore. So it's really fascinating because Kubernetes achieved all little things of a networking part. It can save your life, honestly, to establish millions, billions containers or what I say, applications. It's really fascinating. And also I have to tell you, in my book, I will share, very, very little bit, it's kind of a history. I am writing some history and also each little bit, because if you delve into the specific aspects, I can just share you a couple of hours. But today I just give you the most precious part. Yeah, it's kind of a conclusion. That's it. Okay. Okay. I want to ask you, as I'm from India, I intend to do my master's in US. Okay. So to become a cloud engineer, which master program I should be doing? Okay. Computer science or specialization in software engineer. Okay. Your master. So what's your bachelor degree? You didn't say. What's your bachelor? Because your bachelor degree is also quite important. You want to be a cloud engineer. Oh, which master program? Okay. Actually, for for academic and also the realistic work, or in computer science, wonderful. Yeah, it won't be in India. Okay, lovely. Yeah, my bachelor's degree is also computer science. Can you share the link to your website? I cannot. Okay, it's really easy. xpetersu.com. xpetersu.com. Easy. Yeah. My GitHub, my YouTube, my Twitter, all xpetersu. It's my nickname in the tech industry. Okay. Just let me answer also question. Um, I think for the academic part, sorry, I have no some suggestion, but for your future working, your future job, I think I can share some experience. For cloud, okay, where is it? Cloud engineer. Okay, for cloud engineer, I have to tell you because I don't know why we have so many titles changed. Because for our cloud engineer, we also call them DevOps. So what I mean is because for cloud, it really depends on which kind of purpose or which is your goal. If you let me tell you the top one because we have limited time. Let me just tell you some top one, and then you will when you think about the top one, if you just take action, you will at least get the middle level, right? So let me tell you the top one. So what you can achieve the big cloud expert, it means you need to be proficient in different fields, not only like your background, the bachelor degree is computer science, really lovely. So it means a cloud engineer, if you want to be the top one, what does it mean? You need to be very proficient in networking, Linux, system administration, and also Python. Yeah, the code, shell scripts, etc. Yeah, you must familiar with it. And also what I mentioned, these container technologies. If you let me tell you, because you are the students, but in the tech world, I think most of them, especially like big firms, they definitely use Kubernetes. For example, like what I get the data from the AWS and Alibaba, there's the most popular product is, for example, EKS in AWS and ACK, just a different term in AliCloud. But what I mean, if you just get along with and learn different aspects of knowledge, knowledge is generic, is general, no matter which which cloud provider you use. For example, like AWS, Azure, Google, no matter what kind of cloud providers you use. No worries, even you have no experience, but the underlying knowledge you must know. For example, today, if you are familiar with the Kubernetes networking architecture, in the future, even the AWS or even the Alibaba, no matter, you know it, you know what they're customized. There's a specific product, right? You know how they run together. Oh, this part I need to focus on. When something get trouble, you will be the expert to do the troubleshooting. So no matter what happens, do just focus on, do have broad knowledge, and also find something you're really interested in and broaden it. Do have the whole picture in your mind, not just the only part. Doesn't mean you need to be proficient in everything, But at least you need to have this overview. You have the full picture, but you can draw a little bit the emphasis on different, some fields you really interested. That's it. I hope I just answer your question. Okay. And thank you so very much. Keep in touch. If you have any questions offline, just let me, find me. You will definitely find me. Yeah, from my website. Yeah, etc. And I hope if you are curious and just stay tuned with my book. Thank you.